All right, in this lecture video, what we're actually going to get into is a discussion about the sort of internal decision making that occurs amongst competitive firms in a competitive market. Up to this point, we've thought about competitive markets broadly, and we thought about them in terms of an assumption about the aggregation of producers, right? So the supply curve that we've discussed in class up to this point has been assumed to represent all of the firms in a given market, differentiated by, of course, their position on the supply curve in terms of their willingness to accept either a high or low price. And we've kind of sort of discussed how if you're at the high end of the supply curve, then you're a high cost firm, and this means that you have a high willingness to accept, meaning that you require a higher price, and which makes sense. So higher cost firms are going to require a higher price for their product. Think about sort of organic milk versus cheaper milk, which would be from producers on the low end of the supply curve who have lower costs and therefore have lower willingness to accept. And that's really how far we've gotten with that particular discussion. So what we're going to do now is actually discuss what's going on in the market around firms that lead them to make these particular decisions. All right, so first let's bring back something that we haven't talked about for a long time, but we actually talked about it towards the beginning of class, and that was what actually motivates business decisions in our model. Our model business decisions are made exclusively because of profits, and most importantly, we say that firms are profit maximizers. So what does this mean? Well, if we look at the profit function, again, we can see that the profits are going to be equal to total revenue minus total cost. And one of the things that I always did when I was an econ student, and then even now as a professor, is I want to simplify things as much as possible for myself. I want to be able to break things down very quickly. And so when I look at this particular portion of the profit function, P times Q, this is that total revenue, right? This is the amount of money that you have coming in to your firm from the sale of your good. And so it's simply the price of your product times how much of that product you sell. And then for right now, we'll keep total cost as being this simple, just total cost function. Now, it is important, and we have discussed this previously, for us to remember that in economics, we're always thinking about both explicit as well as implicit costs. Explicit costs being, your labor, your input cost, all the things that explicitly cost you money to run your business. And then there's also all these implicit costs. So implicit costs are the opportunity cost associated with the production of whatever good you're choosing. So our assumption is that if firms are profit maximizers, they're also taking into consideration all of the other business ventures that they could be doing, and that therefore, whichever business venture they're currently doing, that's what's best for them. It's a very simple, relatively innocuous point to make, but it keeps the model rational. It keeps the model relatively straightforward. So, what we learned previously in class was that we can generally think about the profit function as we increase our quantity sold. We can think about the profit function as increasing and then decreasing, kind of a classic diminishing marginal returns. So the idea here is that the goal of business will not simply be to produce as much as possible or even to sell as much as possible, because in fact, what is going to happen is that when we're in this portion of our profit function, our revenues are rising faster than our costs, and so our profits are rising. But when we get past, in this particular model, 500 units, we can see that now my profits are falling. And this means that my costs are now rising faster than my revenues. And so oftentimes students sort of naively believe that the goal of business is simply to sell as many of your product as possible. But that's not really true at all. Firms have to take into consideration costs, and costs tend to balloon as you try to produce more and more and more of your product. Again, because of diminishing marginal returns kind of add up and pile up. And so if I just try to produce as much of my product as possible, I'm going to have very inefficient workers with a lot of inefficient capital being used. And as a result, my profit function or my business function will be highly inefficient. So really the whole point of all this discussion is to say that firms are looking for profit maximizing quantity. They're looking for that quantity that literally is the peak of their profit function. Here we can see that for this particular firm, their profit maximizing quantity was 500 units. Um, Now it's important for us, and we'll see this in just a moment, to recognize that profit maximization by choosing a particular quantity will require us to know price as well as know total cost. How else could we pick a quantity to maximize profits if we didn't know price and we didn't know our total cost? But for right now, let's just assume that there is a particular quantity for us to pick that does indeed maximize our profits. Now, when we think about cost, we're going to want to differentiate between cost in the short run and cost in the long run. Right now, we're going to live in a world purely of the short run. And what this means is that our total cost function is going to be unique. In the short run, total cost is made up of variable cost and fixed cost. Okay, again, variable cost and fixed cost. And these two costs make up our total cost function. And here we can see an explicit version, a specific version of a total cost function. So this is one I just made up, but this is pretty reminiscent of what we would assume to be a general cost function. And so variable cost is defined as those costs associated with production. So if we look at our total cost function, anywhere where there's a Q, that is to say anywhere where our total cost changes relative to a quantity, that's going to be our variable cost. So we can look at total cost function. We can see that 2Q squared minus Q plus 1,000. Well, there's no Q over here, so this has nothing to do with variable cost. And so our variable cost is simply 2Q squared minus Q. And again, the point of variable costs is that these are costs that will change with how much we decide to produce. So if we were to produce more, for the most part, variable costs will rise. And if we want to produce less, for the most part, variable costs will fall. Now, fixed costs is that unique part of the short run cost curve. So in the short run, we have unavoidable costs. These are things like leases and rentals and even contracts that, despite how much I produce, I still have to pay these things. So if I lease a factory, for example, to make a bunch of shoes, and then I decide halfway through the year that I don't want to make any more shoes, I am not able to get out of that lease. So I have to keep paying that lease for the full year, regardless of how much I produce. And so this is why we consider fixed costs to be unavoidable in the short run. And if you look at our total cost function, fixed cost is just that chunk of our total cost function that doesn't have a quantity associated with it. So here we can see that fixed costs are 1,000. You can think about fixed cost in a sense as being sort of the entry fee into a market. We'll find out later on that we need to have profits that are at least larger than our fixed costs, than sort of the negative amount of our fixed costs for us to stay in business, for us to choose to continue making products. So you can really think about these fixed costs as being kind of the hurdle that a business would have to jump over before they can even think about producing their product. And so this is ultimately why in many markets we have barriers to entry because fixed costs can be very high. In certain industries, fixed costs become barriers to the prevention of competition because small startups are unable to come up with the fixed costs necessary to get into a particular market. Like say the computer industry, for example, can be a very expensive industry to get into. While computer components themselves are quite cheap, the actual apparatus of selling computers itself is quite difficult and carries with it a tremendous amount of fixed cost. That's kind of besides the point, and we'll get to talk about those discussions a little bit later. But for right now, let's just sort of think about fixed cost as being that chunk of our total cost function that has nothing to do with quantity. And sort of regardless of how much we produce in the short run, we will have to pay our fixed costs. So, as I probably don't have to tell you, firms, producers, use their cost as metrics. What I mean by this is that they use their costs as decision-making apparatuses. What I mean by that is that they look at their costs and they use those costs as a specific determination of what decisions they should make in the short run. But they don't simply look at total cost. They look at costs from a little bit more of a specific um, position. And so, two of the more important types of costs that we're going to discuss in the course is average total cost and then average variable cost. Um, Average total cost is simply total cost divided by Q. So as you can see here, we take that total cost function, we divide it by Q, we do some simplification here. But the main point here is just that average total cost tells us basically on a per unit basis how much is each unit of our product costing us as sort of a piece of our total cost story. Now, average total cost is a very important cost metric that nearly every company knows very well and uses in their decision making process. But what we'll find out is that average total cost can be a bit of a mirage in a sense in terms of business decision making, in that it is a very important metric for us to understand, but ultimately it doesn't actually make a decision for us. We'll actually look at other costs, and we will use those as kind of those decision making pieces. And average total cost will really become a way for us to measure cost, to actually measure how much cost is accruing to a firm given a particular amount of production. And that sort of same story goes with average variable cost. Average variable cost is just our variable cost divided by quantity, and it just tells us kind of relative to our total cost of production, again, that just variable cost piece, how much is each unit costing us roughly. It's not a super, maybe sort of important or specific cost, maybe not as important as total cost, average total cost rather, but it's still going to be something that we're going to need in our analysis because it becomes, again, that decision making component. And what we're going to find out is that the average total cost and average variable cost curves, while not necessarily being the main decision making components of profit maximizing decisions, are themselves very important curves because they do tell us something about the relative profitability of a firm, or whether the firm should even stay in business. And then lastly, and perhaps most importantly, is this concept called marginal cost. Now, marginal cost, as we'll find out, is actually going to be that decision-making piece. Spoiler alert, it actually ends up being the firm's supply curve, but we'll get to that here in just a moment. The marginal cost curve is a little bit ambiguous at first. Students have a hard time kind of really understanding what's going on. So let's kind of take a step back and let's go back to the average total cost and average variable cost curves. And let's look at this graph over here to the right. So we can see the average total cost curve kind of starts out flat, might even decrease here a little bit at the beginning, and then eventually rises. The same with average variable cost. And then we can see that marginal cost kind of does the same thing and then rises. Now, average total cost, as quantity rises, we can see stays kind of flat for a bit and then rises. What that tells us is that um, when we produce very little of our product, our costs are pretty contained. And so the curve itself is relatively flat, or at least it could even be falling. And we'll see that in a curve here in just a moment. And then once it gets past marginal cost, we see that it rises and really kind of starts rising precipitously. And again, this goes back to this concept of diminishing marginal returns. I cannot simply produce a quantity of a good more and more and more and not expect my cost to rise very quickly. Now, marginal cost is that metric that says that total cost, the change in total cost rather, is divided by the change in quantity. What this tells me is that as I produce that next product, how much is my total cost changing? Remember, you can think about marginal costs and marginal revenues and marginal utilities and whatever the marginal concept we're discussing. You can think about them in terms of that next incremental change. So how much does my total cost change as I produce that next product? And you cannot think about this without thinking about sort of the level of quantity that we're currently at. So we want to think about marginal cost as being, okay, let's say that I'm producing 10 units of my product and my costs are $100, and then I produce that 11th unit and my costs rise to 110. Well, this means that my marginal cost is $10 for that 11th product. So specifically, that 11th unit of my production cost me $10. It sent out $10 in the form of input cost, labor cost, capital cost, whatever. And then I go to produce that 12th unit. and let's say that my costs rise to 115. So my costs are still rising, but my marginal cost has actually fallen to 5 units. So that 12th unit has a lower marginal cost than the 11th unit. This is important for a firm to understand because we want to think about decision making as being on the margin. What that means is that decision making is made very incrementally. Do I want to produce my next unit? Well, I want to ask myself, how much money am I going to have coming in for that next unit versus how much money am I going to have going out for producing that additional unit? And only when those two things are maximized against each other, that is to say, that when the profits that are coming in are maximized, will I choose to produce that additional unit. This is this sort of hyper rationality that we project onto competitive markets. Now, of course, we're living in a world that's a bit automaton here, meaning that we're assuming that essentially firms are perfect and make perfect decisions. In the real world, however, though, you can still imagine that it would be a unique and perhaps even successful attempt to find that profit maximizing quantity by just looking at your profits at different quantities and seeing at what point does a very high amount of quantity actually reduce my profits. And then that tells me how much I shouldn't produce. And then sort of as I go back, how little of my product produces a lower profit. And then that kind of gives me a range that I can choose from that I'm reasonably certain gets me close to profit maximization. So let's actually talk about that. All right, so let's remember that what we're describing here ultimately is the supply curve in the supply and demand framework, right? And so that, again, this graph is representative of many firms. Now we're thinking about things in terms of per firms, individual firms. But again, ultimately, all of the individual firm decisions will be aggregated up into the supply curve. Notice that as the price of the product rises, the willingness to supply the good rises, and we'll see why in just a moment. So obviously, if we're going to frame all of this around supply and demand, we have to go back to our competitive market assumptions. So recall that we assume that we have atomistic buyers and sellers. And essentially, what this means is that there's so many buyers and so many sellers that no one buyer and no one seller can affect the market. We assume perfect information. That is to say that both consumers and producers have perfect information about what they're buying, what they're consuming, and ultimately that the transaction that occurred is mutually beneficial. We also assume in supply and demand somewhat rigidly that all products are identical. So if we're talking about the tomato market or the craft beer market, we're essentially assuming that they're all the same. Now, we have talked about in class how we can differentiate between low quality products on the low end of the supply curve and high quality products on the high end. And we can do this generally, but specifically when we talk about at equilibrium, given that equilibrium is at a particular price, our assumption is going to be that these 500 units at this particular price of excuse me are of a uniform quality. So because they're only at one portion of the supply curve. So ultimately, the actual good itself is ultimately homogeneous. Um, and then lastly, we have free entry and exit. What this means is that firms can get in and out of the market essentially costlessly. This becomes really important. In fact, later on, we'll kind of think about this as in a sense, the oil in a competitive industry that keeps the system lubricated and keeps it moving and working efficiently. When we talked about these four competitive market assumptions earlier in the course, we framed them around ultimately the biggest assumption of the supply curve, and that is that producers are price takers. That is to say that producers don't set prices in competitive markets; that prices are set by the market, and then firms respond to them. So this is a really important point. When you think about the decision of profit maximization for a firm in the competitive market framework in this theory, we're assuming that prices are set by the market and then firms respond to those prices by selecting a profit maximizing quantity. This decision sort of ordering is very important because it ultimately goes on to explain some of the behavior that we assume will occur in competitive markets as we move from the short run to the long run. And so now is an important time to point out again that we're discussing the short run. and that later on we'll discuss what happens to competitive markets as we move into the long run if we assume all of this behavior that we're outlining here. So ultimately, the we just talked about costs, and so ultimately, since profits are about revenues and costs, we of course need to talk about revenues as well. And so here we can see that total revenue again is just the amount of the product I sell times the price. And since the price is set by the market, we can go ahead and slap a star on there, and we can say that this is the amount of the product that I choose to sell times the market price, because we are going to assume that I'm a price taker and that I will simply take that price. Now, if we recall the definition of marginal revenue, again, that change in total revenue divided by a change in quantity, that incremental change in revenue when I sell an additional unit of my product. Let's think about this for a moment. Let's say that the current market price for a high quality tomato is $5.50. So right here at this equilibrium right here, $5.50. All right. Now, if I think about this and I assume that I always sell tomatoes for $5.50, and I ask myself, well, how much does my total revenue change when I sell my next tomato? The answer will always be, regardless of how many tomatoes I'm currently selling, will always be $5.50. If I always sell at the market price, then lo and behold, market price is my marginal revenue, which is, I think, a very sort of straightforward point, but it can be somewhat tricky sort of for the first time student. So it's important for us to establish very specifically that in perfectly competitive markets, the market price is always equal to a firm's marginal revenue. And again, ultimately, what we're going to do is we're going to use marginal revenue and marginal cost to make a profit maximizing decision. So let's see how that works. Okay, here we see a very typical, straightforward illustration of a firm's short run cost curves. So we have our average total cost curve, we have our average variable cost curve, and we have our marginal cost curve. And then what we also have here is we have three different market prices. So we have a market price of $15, we have a market price of $50, and a market price of $150. Right? And remember, we expect prices to fluctuate in a market over time because we expect firms to be getting in and out of the market, or even we expect the demand to be shifting over time. And so market prices do rise or fall over time. And as supply rises, all else equal, then we expect prices to fall. And as supply declines, all else equal, we expect prices to rise. Basically, the more suppliers there are in a market, the lower the price is going to be. The fewer the suppliers in a market, the higher the prices are going to be. So you can generally think about these different market prices as being different amounts of firms in the market. Again, with this top one representing the least amount of firms and this bottom one representing the most amount of firms. Okay, so let's go back to our profit function. So our profit function is total revenue minus total cost, which is just Q times P star minus Q times average total cost. Because if you go back to the average total cost function, average total cost is equal to total cost divided by Q. If I just solve that equation for average total cost, I get, excuse me, if I just solve that equation for total cost, I get that total cost is equal to quantity times average total cost. So it becomes a very simple way for me to quickly calculate profits. This is what I was saying earlier, is that ultimately the average total cost and average variable cost curves themselves are not super important, because what we're going to use is we're going to use marginal cost and marginal revenue to determine profit maximizing quantity. But we use the average total cost curve to calculate profits, and we'll see how. So our rule for profit maximization under perfect competition is that marginal revenue will be set equal to marginal cost. Okay, again, that marginal revenue will be equal to marginal cost. It is at that point where my profits will mathematically be optimized, where my profits will be mathematically maximized. And so therefore, the firm responds to a particular market price by producing a particular profit maximizing quantity. So for example, if the market price is $150, the firm sees that 1,000 units of the product is where $150 intersects their marginal cost curve. Therefore, they will choose to produce 1,000 units to maximize profits. If the market price falls to $50, the firm will respond by producing 800 units instead, Notice that, as we would assume, as with the law of supply, that as the price falls, the quantity supplied will fall as well. And then we can see even further that as the price falls to 15, if the firm were to still produce where marginal revenue equals marginal cost, the firm would produce 200 units. We'll actually see in just a moment that if the price were to fall to $15, the firm would actually get out of the market. Okay, so let's actually calculate some profits. So let's suppose that the market price is currently $150. Okay, the firm responds again by producing 1,000 units, and so total revenue is going to be $150 times 1,000 units minus 1,000 units times the average total cost at 1,000 units, which we can see is, if I look at the graph, at 76. So 1,000 times 76, and I calculate that up, and that gives me $74,000. What this tells me is that the firm is currently making $74,000 profit if marginal revenue is 150, which means if the market price is 150. If the market price were to fall to 50, the firm now responds by selling 800 units, and so 800 units times $50 minus 800 units, and then we just go back up to the average total cost curve, and we see that at 800 units, average total cost is at 60, and so 800 units times 60, and I do the math, and I get a profit of negative $8,000. Now, sometimes students are a little worried about negative profits because they tend to think about profits as only being positive. But actually, you want to think about profits as just being a flow of money, which could be positive sometimes and could be negative sometimes. In fact, most small businesses don't earn profits in the first 2 years. And so you actually have 2 years worth of accumulated negative profits that you have to deal with. And so negative profits are in themselves not really an issue and isn't necessarily a reason for a firm to get out of the market. But what is the reason for a firm to get out of the market is if the market price ever falls below average variable cost. So if we look at price here at $15, we can see that it intersects the marginal cost curve at a point that is below the average variable cost curve. Now what this means is that if the firm were to produce at this particular amount, they wouldn't even be covering their fixed cost, right? Because again, you can think about fixed cost as being the distance between the average variable cost and the average total cost curves, right? And so at this particular quantity level, they would no longer even be covering their fixed costs. And so the firm actually would do better by just getting out of the market and paying their fixed costs. They actually would make less negative profits by simply getting out of the market and just paying their fixed costs. And so the general rule is that anytime you have a price that is below average variable cost, the firm wants to shut down and get out of the market. And so the rule is not simply that the firm makes a negative profit. We can see that at a price of 50, the firm makes a negative profit, but still would choose to stay in the market. But at a price of 15, since we are below the average variable cost curve, this means the firm is not covering their fixed cost and therefore would get out of the market. And to this point, we have a very simple kind of breakdown for you to think about when you're sort of formulating what are the kind of baselines for decisions. And so we can think about sort of two very specific and important points. The first one, which we've already kind of discussed just previously, was this shutdown point. And that shutdown point is going to be at the minimum of your average variable cost curve. So our average variable cost curve here, and we can see that the price here that's at that minimum is going to be what we call our shutdown price. And so any price at or below this price is actually going to cause us to shut down, get out of the market, pay our fixed cost, and either go try something else or just go get back in the rat race that our small business didn't work out. If the price is ever above the shutdown price, then this means the firm wants to stay in the market. Now, if we're below the break even, so the break even is the zero profit condition. So we can see if we were to think about this in terms of profits at a price of the break even, we would go over, we would produce the break even quantity. I would go back up to find my total cost, and I could see that total revenue is equal to total cost here. And so this is where we make zero profit. So between the shutdown and the break even, firms are earning negative profits, but they're staying in the market. Now, oftentimes what economists say is that they stay in the market, but they're thinking about getting out. And then if the price ever falls again below the shutdown or to the shutdown or below, then they actually do want to get out of the market. But if the price is in between this zone, then they're staying in the market, but they're thinking about it. And then, of course, the big one is that if the price is ever above the break even, then the firm is going to be earning a greater than zero profit, which is, of course, what every firm wants to do. It's important for us to realize that even if a firm produces in this area here because of a market price and they earn a negative profit, this doesn't mean that the firm is not maximizing profits. Again, it's just like utility. We assume that we're always maximizing utility, that the decisions we're making with respect to consumption are always doing the best with what we have. And we assume the same thing in firms. So when a firm is earning negative profit, we're left to assume that that is because of market conditions and not necessarily because of poor business decisions. Now, of course, in the real world, the markets are rife with very poor business decisions, and arguably the big issue with small businesses is probably a lack of business acumen. But one should not, I think, neglect to also recognize that markets themselves can be really difficult to navigate. And so some of it really is just purely market conditions. All right, so to wrap all of this up, perfect competitors are price takers, which essentially means that they face a perfectly elastic demand curve. That last part's not super important, but if you think about what a perfectly elastic demand curve is, a perfectly horizontal demand curve, then you can see that this would mean that the firm would have to charge that market price. That they couldn't charge a price above or a price below, because in fact, a perfectly horizontal demand curve would mean that there would be no demand above or below it. And so again, you can see that this locks the firm in to charging that market price. Firms set marginal revenue equal to marginal cost by choosing a quantity that maximizes profits. So we saw that in the previous slides that the firm will see where the marginal revenue is, which again is the market price, and will choose the quantity that aligns marginal revenue and marginal cost. And this will mathematically be the profit maximizing decision of the firm within the context of the market conditions, most specifically the current condition of the market price. The market price is always a firm's marginal revenue. So what this ultimately means is that a firm makes a decision based upon market conditions and their own cost structure. Okay. If the decision to make a quantity is based on marginal revenue, which is the market price, and marginal cost, which is from the firm's cost structure, then this means that the firm's cost structure, that is their own identity, sort of intermingles with the market conditions and produces a profit maximizing quantity. And so this is really the way I want you to think about markets and how they work. It's not so much that you have all of these firms making very specific decisions and then that's what creates market conditions. Okay, the way we think about it is that market conditions exist and then firms are making decisions within that context. Lastly, marginal cost curve is the firm's short run supply curve. If you go back and you look at the previous curve, and you'll notice that every time the marginal revenue rises or price rises, our framework tells us to produce more. And every time the price falls, which means the marginal revenue falls, this framework tells us to produce less, which is exactly what the supply curve tells us. As the price rises, I'm willing to supply more. As the price falls, I'm willing to supply less. And because I specifically produce the quantity that aligns marginal revenue and marginal cost, the marginal cost curve is literally the firm's short run supply curve.